A pollutant was dumped into a lake, and each year its amount in the lake is reduced by 25%. A. Construct a general formula to describe the amount of pollutant after T years if the original amount is A sub 0. Let's begin by making a table of values, and then we'll look for a pattern. The original amount is A sub 0, so when T is equal to 0, the amount of the pollutant can be symbolized by A sub 0. We're then told that each year its amount in the lake is reduced by 25%. So let's think about the process. We start off with A sub 0. That's the beginning amount. But then we need to take away 25%. A common mistake is just to subtract 25% or 0.25. But what we're doing is we're taking away 25% of the original amount. So we need to multiply the 0.25 by A subscript 0. We're starting off with the original amount, A sub 0, and then taking away 25% of the original amount. Well, what does that leave us with? We started off with 100%, we took away 25%, we're left with 75% of the original amount, or 0.75 times A sub 0. So after 1 year, the amount of pollutant in the lake will be 75% of the original amount, which can be written symbolically as 0.75 times A sub 0. How much will there be after the second year? Well, what we'll need to do is we'll need to decrease the amount in the first year by 25%. We could go through the same process that we did before, but remember the end result is that if you decrease something by 25%, then you wind up with 75% of the original amount. So what we need to do is to take this 0.75 times A sub 0 and multiply it by 0.75 again, and what we end up with is 0.75 times 0.75 times A sub 0. But 0.75 times 0.75 can be written as 0.75 squared. So we have 0.75 squared times A sub 0. Similarly, for year 3, the amount of pollutant will be 0.75 cubed times A sub 0. So what is a formula for the amount after T years? The formula will be A of T is equal to 0.75 raised to the number of years times A sub 0. Common notation would be to reverse the order and write this as A of T is equal to the beginning amount, A sub 0, multiplied by the decay factor, 0.75, raised to the T. So this is the general formula to describe the amount of pollutant after T years. Part B says to use a symbolic approach to determine how long it will take before the pollution is reduced to 10% of its original level. Well, 10% of its original level is 0.1 A. So what we want to do is to solve the equation A of T is equal to 0.1 times A sub 0. So what we can do is just substitute this expression for A of T. Substitute A sub 0 times 0.75 to the T for A of T. So we end up with A sub 0 times 0.75 to the T is equal to 0.1 times A sub 0. Now our goal is to solve this equation for T. So the first step will be to divide both sides by A sub 0, our original amount. So if we divide the left side by A sub 0, we end up with 0.75 to the T. And if we divide the right side by A sub 0, we're left with 0.1. Notice that t, the variable that we're trying to solve for, is an exponent. We want to recall that exponents are logarithms. So what we're going to do now is to take the logarithm of both sides. Using the properties of logarithms, we can take the exponent and multiply it by the logarithm. So we end up with t times the log of 0.75 is equal to the log of 0.1. Finally, in our last step, we can divide both sides by the log of 0.75 to get our answer. So t is equal to the logarithm of 0.1 divided by the logarithm of 0.75. We can use a calculator to get an approximate value. Our answer is approximately 8 years.